Hey guys, welcome to question FM152 of the Further Maths Fortify study guide. So this question reads, a sequence is generated by the recurrence relation Tn plus 1 equals Tn plus 5, where T1 is 7. The nth term of this sequence is what? Now, this question wants us to find the nth rule for this recurrence relation. What you may be used to using when trying to find an nth rule is this formula here, which is Tn equals A plus Nd. And then you fill in the blanks for A being the first term in this sequence and D being the difference that's being applied. The little trick in this question is in the fact that they've given us this T, well, the first value of T in this sequence and not T0, which is what we would usually use for this kind of formula. So there's going to be a slight difference in our formula because we're going to be using this first term, so this 7 as our value for A. And that slight difference is going to look like this. Tn equals A plus N minus 1. Now all we've done is minus 1 from N. This N is still multiplying the D here, except that now we're using N minus 1 instead of N. So this slight change, we're bringing it in because this is a value of T1 instead of T0. I can show you how that works. In fact, I might just show you how that's going to work sort of in relation to this as opposed to having a value of T0. So if we, I'm going to show you the answer to this first and then I'll prove it to you. So now when we fill in our spaces, we're going to have this Tn rule. Our value of A we're going to use 7 plus, and our difference is positive 5, so we'll leave this as a plus, 5n minus 1. This answer is looking a lot like option E, which is our correct answer. And now I want to show you how we're going to use this answer. So anyone who is confused in why we're using this n minus 1, now hopefully this will help to explain a little bit. Now, if we were to have a value of T0, so let's pretend that we had, in this sequence, if we had a value of T0, that T0 would be 2. So if we were to apply that to this equation here, we would have an nth rule of Tn equals 2 plus 5n, which would mean that if we were to put a 0 in, we would find T0. This would be equal to 2 plus 5 times 0, so no differences have been applied yet. So this will end up being 2 plus 0, which gives us a value of 2, and then the next value, T1, is going to be 2 plus 5 times 1, so it's bringing in one of those differences of 5, which takes us to 7. But because we're given this T1 value, and we're starting at 7, we need to make sure that a difference isn't applied when we first step into this sequence. So when we have this T1, using our actual nth rule equation here, T1 equals 7 plus 5. Now I've given n a value of 1 here, so I must also give an n a value of 1 up here. Now you'll see hopefully why this n minus 1 business is applied. In our first term, we don't want a difference of 5 to be applied, so we need whatever 5 is being multiplied to come to 0 so that it isn't applied. And that's exactly what we end up here. When we have 1 minus 1, we end up with 5 times 0, which just leaves us with that 7 we began with. If we didn't have n minus 1 here, if we just had n, let's say, it would immediately apply one difference of 5. So we'd be at 12 on our first term, which doesn't line up with what we've been told about this sequence so far. Hopefully that somewhat explains why we're using this n minus 1 instead of n. If it doesn't, please leave a question in the comments below and we'll be happy to get back to you. Otherwise, see you in the next video.